this class is related to moment diagrams, and I will be doing some problems of past years, problems from midterms and quizzes from the past. The first problem is a very simple one. I will not be resolving this problem. However, I want to show you that sometimes we can have a beam where a part of the beam is on cantilever and there is no force acting on it. Well, the diagram of shear will be a straight line until the moment that we arrive to the first force. And this first force will be minus 68 plus 89, that is 21.111 going up, because this number is bigger. The same will happen with the diagram of moment. You will have a straight line, and after you start with an inclined line because you have a box. The second problem has the particularity that we have there a force of 40 pounds per foot, and this force that have a total value of 320 because we need to multiply by 8. Many books is represented like this. We create a inclined line, but this inclined line form two triangles that are different. Therefore, we need to calculate this distance under that triangle and this distance here. That will be the base of both triangles. Well, let's do that. The exercise is easier because we can substitute 40 by 320 in the middle, and we calculate the moment here. All these moments could be negative, all these elements could be negative, and this is positive. And well, we can easily calculate the two reactions, 202 and 168. That is the first part of your problems always, unless I give you this number, like in this exercise. Second, we need to calculate the shear diagram. Calculating the shear is simple because it's like doing a balance in a bank. You imagine that you always start in 0 and finish in 0, and forces will move up and down exactly like vectors. Well, 202 is the vector pushing up, that is this one. Nothing happens. I have a force of 320, and because it's distributed, will be an inclined line. I start in 0, and I need to go down 320. That is the dimension of this yellow vector that we have there. And this dimension is 320, but because I have 202, I need to write in my diagram 320 minus 202, that is minus 118. 320 will be negative because it's pushing down. Well, I got this point, and after I just need to put those two points together, and it will be this line. Interestingly, the shear appears to pass through 0, and when that happens, we always have a new line for the next diagram. Next, nothing happens. I will do that in green color, and therefore I go with a straight line. Thereafter, we have a force that I will color code in red. We need to go 50 pounds down. We used to have 118 minus 50 because it's pushing down. We have 168. Finally, the last part in pink color, nothing happens. Well, I go straight. And at the end, this number, 168, need to be the same of the distance that I am supposed to go up. That this time will be in blue color. I go up 168, and I finish in 0. Well, I already got the diagram. It's very straightforward. Next, I need to calculate the next diagram. And in order to do so, we have several methods. In this class, we are studying only the method of area or area method. Let me make a little bit small this and do it here. Why we use this method? Well, because always in all the other methods, we imagine that we got the beam in a point. For example, we got the beam here. The moment will be what we have at the left, that is 202 multiplied by 4. And if we calculate the moment here in 12, for example, it will be equal to 202 multiplied by 12 and 320 multiplied by half the distance. That will be 4. 320 negative multiplied by 4, etc., etc. And that is the same to calculate the areas. It's exactly the same. Well, let's look. The first one was 202 multiplied by 4. 202 multiplied by 4 is 808. Is this area, and that is exactly the first point that I need to plot. The next one will be 202 multiplied by the distance, and I am cutting in 12, and it will be, let me clean here, it will be 202 multiplied by 8, all this particular area in yellow, in that square, plus 320 multiplied by the distance, that is 4. And 320 multiplied by the distance, that is 4, by coincidence, is this area. When we take the big one, yellow, and eliminate the red, we have the answer. And that particular answer will be this area that we need. That is this. Etc., etc., etc. Well, let's do it. First, we already did 202 in yellow multiplied by 4. We plot 808, and we do this color code in yellow, only for your reference, but you don't need to do it like this. Second, I am already in 802. I already count this area. Well, I need to do this one. How much is that area? We don't know, because remember, in the diagram before, we made this line, and we have now one new line, because the shear passed to 0, and we don't know how much is the distance that is equivalent to the base of this rectangle. And that is a small problem that we need to resolve. And it's not complicated, because we have another triangle. We have a very big triangle here, this one, that we know the proportions. We know the proportion of the red triangle, and the proportion is 202 plus 118. Okay, that is the value of that particular line, and happens to be 320. And we also know the base. The base is from 4 to 12, that is 8. And that is the proportion of my big triangle. I want to calculate the two small triangles. Let's tell that one of them is green, the one in top. And let's tell that the small one is in orange color, yellow, orange, that is this one. Well, this yellow one, that we will call 2, is the same as this 2. Have the same proportion, have the same diagonal. Therefore, those triangles are similar triangles. and they will always keep the same dimension. How I do that? Well, I just tell if I have a particular height of 320 in the red one for a base of 8, for example, for the small medium one, the green one, I have a height of 202, and I want to know how much is the base, that is the number that I put. And this is similar to work 8 hours to make $300, how many hours I need to work to make 202. How you resolve this? This is what is called the rule of 3, 202 multiplied by 8. You multiply here and divide, you divide here by 320. And that is the answer of the number that we need, okay? Happens to be 5.05. Because I already have that number, let me erase everything, that is 5.05. I can calculate this area, 5.05 multiplied by 202, divide by 2, I have this rectangle. I already have this one. Well, I can just tell 8 minus 505. But if 505 was grown, then this area will be grown. Well, I will prefer to do this again. I will prefer to imagine that I have this big triangle and I do the same thing. 320 is equivalent to 8 in the same way that 118, that is the side, is equivalent to the number that I want. 118 multiplied by 8 divide 320, and then I will have a number that in this case happens to be 2.95, I believe. Therefore, 2.95, that is this distance, plus 505, that is this distance, will be equal to 8. Then I can corroborate that the areas were correct. Well, I calculate the areas, let me clear, and I write the areas here. I like to write the areas in a rectangle like this. I don't get confused with those numbers. Well, be careful because you can get confused. I like to write the areas inside. If I cannot write it, I will do something like this. I will have all my boxes put area. I know that the numbers inside of the boxes are the numbers that we'll use to plot the bending moment, and the numbers that are outside the boxes are the numbers relate to shear force. Well, the first one is A08. I calculate the next one, that will be this base multiplied by 5.05. 5.05 multiplied by 202. I will do the same with this one. I will do the same to this one. That is 118 multiplied by the distance, and this multiplied by the distance. And then I plot. I start with A08, and I make this a perfectly straight, a line, perfectly straight. I am done telling you the truth. Well, let's do it. I take a straight line and I go from 0 to A08. Make this sticker. Next, I have an area over there, and I will tell you the number now. Let's calculate fast. That area will be equal to 510. Let me try again. I think that there is something wrong. So I didn't put the decimals. A08, 510.05. Well, I need to go up because it's positive, 510.05. And I do it. I just take my pencil, go up 510. I arrive to this point, and I draw my curve. There are two possibilities. One possibility will be a convex or a concave curve. It can be like this in red, or it can be like this in yellow. Which one is? Well, very easy, because this area here are big, and these are small, means that I am growing fast, a little bit vertical, and I am ending not so fast, because the number is very small. It will not grow the curve so much that it's almost horizontal. Therefore, this is the curve. Let's clean this. We calculate this area, and this area is negative. Well, I need to go down, and again, the first plot is very small, similar to 0, and here is very big, similar to infinite. Well, I go flat, and I finish a little bit more vertical. The curve is like this. The same happens with this. I calculate the area, and now will be a straight line, because this area is a square. Well, I won't do my straight line. And finally, I have another area, the green one, and this area is negative, and the area need to be the same than this number. And it's true, it's 168 multiplied by 4, that is 672. Then my diagram closing 0. Please be aware, many times you will have a lot of decimals. It will not be like this exercise and will not close in 0. No problem. This is not a problem. It will work anyway. Okay, let's go to the next exercise. For the next, it's very similar. But in this case, when you calculate the reactions, reaction 1 and reaction 2, they are already here, but you are supposed to calculate in the test. When you do that, you need to understand that when you calculate the reaction 1 in this point, you put an X, and you will have values at the left and values at the right. This 20, you will substitute by an element here, and I recommend you to draw this again, because it can get messy. This will be 3.5, it will be 3.5, but you already have 7 there. Well, you can get confused. Well, when you do it, when that happens, please do not save time trying to cut corners. Just draw this again, and when you do it, you will realize that 10, when I calculate the moment R1, 10 cannot have the same number than 20 multiplied by 7, that is 140 in the middle, cannot have the same sign. One need to be positive. If you decide this is positive, this is negative, therefore this is positive, and R1 disappear. Be careful about that. Do step by step, write everything, summatory of moments in R1, and write R1 multiplied by 0 equal to 0, because if not, you can lose. In the same way that you notice 1, you can ignore 10. Well, be careful. After we have the reactions, the diagram is quite easy. As you know, we go down 10, go up 63, and right to 53. Nothing happens. We have an inclined line. And when we have this inclined line, remember, we have a new line to calculate, a new value to calculate in the moment diagram. And we will do that now. So make this a little bit smaller. I will not go over the mathematics because you already know, but here you multiply 202 by 4. Let me move this one here. I am integral exercise. Let me go. You will multiply 10 by 4, and you have this distance, this area, sorry, and it's negative, look, it's under the line of 0. Well, instead to go up like we did before, we need to go down. And this will be the representation of this area, yellow color, and we will start in 0 and go down 40. Why? Because this area is 10 multiplied by 4. Next, again, it will be a straight line and will be this area. This area is 53 multiplied by the distance. That is 3, that is 159, I believe. I will change the color, this will be red. Well, I go up 159, and that is exactly what I am doing here. I move the vector, and I make a vector that is 159 long, but because I start in 40, the value that I will plot is 119. You can write 119 here near this point. I like to do it like this. For in this case, because of the drawing that I was using, I just put it over there. We got the second point that will be this straight line. Let's do it straight, and with the part here and go straight directly there. Next, we need to calculate the triangles, and it will be the same. We have a big triangle that will be this one, and this triangle have some values that we already know. Okay. Obviously, the value of that triangle is 87 plus 53. That is exactly what we have here. 20 multiplied by 7, that is 140. Well, we have a triangle that have in one side 140, and in the other side have 7. Well, this is not a difficult one. I just tell 140 is to 7, the same that 53 is to x. And I just can do that in proportions because it's very easy. It will be divided 53 by 3 and divided between 2. That is 2.565. But if not, you can use the calculator and you just tell 53 multiply 7 divide 140, and it's 2.65. You write here 2.65, and this area of this rectangle will be 2.65 multiply the height that we look here is 53. This line is 53. Multiply by 53. And do not forget to divide by 2 because that is a typical mistake. And when we divide by 2 is 70. If I didn't do any mistake, it's 70.225. I will use the 3 decimals. Well, that is exactly what will happen here. From 119, I go up 70.225 and arrive to 189.225. And this is the color code line in pink. Is this line convex or concave? Well, we have biggest areas to plot, we go vertically. We have small areas to plot, we go horizontally. The line will be in this way. If this figure was like this, it will be the contrary. We will go flat here. We will go vertically at the end. Well, the line will be like this. I'm sorry, like this. But that is not the case. Remember, we need to plot this point. That's why we calculate this. And this is the maximum moment. After you have the maximum moment, things are rather easy. You know that you need to cross to 0, and you know that this area is 189.25, and you can finish the exercise. But what happens if you do a mistake? If you did a mistake, I will recommend to just calculate this rectangle. And because you may did a mistake calculating this one, I will do everything again. I will tell if I have 140, I believe what 140, 83 plus 53, yes, 140 for a base of 7 when I have a base, a side, sorry, of 87, how much is? I already know that it's 87. The proportion here is like the same, but I can calculate with the calculator. It will be 87 multiplied by 7 divide 140. And this is 435. If you don't have a calculator, you just calculate in your mind. Look, this number 140 is twice 7 multiplied by 10. Well, you can do the contrary here. You divide by 10, and after you divide by 2. 8.7 divided 2, this is 4, and 7 is 3.5. And that's it. You don't even need a calculator. The diagram closed, everything is correct because 4.35, okay, multiply 4.35, that is this distance, multiply 87, that is this distance, is equal to 87 is equal to 378.45 because we need to divide by 2, the number will be 189.225. Exactly, the area here is exactly the area that we need to finish the diagram from 189.225 to 0. But many times, as I told you, will not be exact. Don't be afraid. There is a tolerance in the test and your answer will be accepted. Well, we're ready with this exercise. Let's clear everything and go to the next. It's very similar. You see? We calculate one area. I will not do it because it's easy, but this area is 20 multiplied by 2, it's minus 40. The next one is 95.385 multiplied by 3, and is like 216.155 is this line. The next one is 50.385 multiplied by 5, and it's whatever I need to arrive to 498. The next one is a little triangle, and I do the same. I just imagine that there is a big triangle here, and this big triangle have a proportion of 50 plus 249. And by coincidence, it's just the same, 60 multiplied by 5. That is the distance. That is 300. Well, I have a triangle here of 300. Let me write here, 300, sorry. 300 in the side. I know that here is 5. Well, my proportion will be 300 is equivalent to 5, exactly the same that the small triangle that I will put in green color, this one here, that has in one side 50.385. I use the decimals at least 3 equal to the number that I want to know. X, the number that I need, is equal to the first one, 50.385 multiply 5 and everything divided by 300. You multiply, you divide, and you have the number. After you have the number, you have the area. Do this again to calculate the other side and have the area. Put the areas together and make sure that it's 300, okay? Because that is, sorry, it's not 300. Put these two lines together, sorry. Put the green line and the red line together and make sure that is 5. Then you don't have problem. You have this area. This is an area that is positive. You need to go up a little bit. And this area is negative, and by coincidence, need to be 519.235 or approx. And curve that is small in changes, curve that is big in changes means start almost flat, finish almost vertical. This is the curve. Well, it will not be this curve. This curve is a curve that works for this triangle in yellow color. Yeah, big, vertical, small, a 10, horizontal. Well, I hope all of you already know how to do all this stuff. You have one more exercise here to practice. And you have a second one here to practice. Please be careful. Sometimes, by coincidence, this will happen in the middle, but if it is not in the middle, you need to calculate. And this distance is bigger than this second distance. You need to do all the calculations. You will have one of the exercises of the test will be similar to the elements that I showed you before, and the other one will be similar to exercises that we did in the past or from the book. This concludes this presentation.